Hello and welcome to the walking talking topic on circle theorems, question number 10 with me, Mr. Barton. Now once again we have a fusion of algebra and geometry to finish our circle theorems run through. So let's have a look. Points A and B lie on the circumference of the circle with centre O. PAQ and RBQ are tangents to the circle. You were given that AQB equals 2x. Let's just get that one in there, where x is measured in degrees. I'll tell you what, this pen is getting dodgier and dodgier every video here. That's equal to 2x. Write down the size of AOQ. Now that's hard because we haven't even got AOQ, so let's join him on there. A to O to Q. So we want that angle there. In terms of x, give reasons for your answer. Okay, so let's break this down. If we've split this line in half here, and that used to be 2x, I'm pretty sure that's going to be x there. And I best just write that down. So A to Q to O equals x, and I'll put the reason that I have bisected angle AQB. So bisected, chop that one in half. And the reason I know, by the way, I've chopped it in half, if you want the kind of technical reason for this, that's a tangent to this circle, A to Q, and B to Q is also a tangent to the circle. And you know that those two lines have got to be equal to each other because of the two tangents theorem. So let's just jot that down there, the two tangents theorem. So we know those two lines must be equal to each other. We also know that that angle there must be 90 degrees and that angle there must be 90 degrees because a tangent meets a radius at 90 degrees. So let's just jot that down as well. So QAO equals 90 degrees because of the tangent meets radius at 90 degrees. So yeah, just going back to why these angles must be the same. We've got a 90 degree, we've got a 90 degree, we've got a side that's the same length and a side that's the same length. And what we've also got here is we've got two radiuses which must also be equal to each other. So those two triangles are congruent, they're the exact same triangle, so those two angles must be exactly the same as well. So anyway, we've now got a 90 degree there, we've got an angle x there, and all we need is angle AOQ. Well, that's not actually too bad because we know angles in a triangle add up to 180 degrees. So A to O to Q must be 180 degrees. We've got to take off our 90 degrees and we've got to take off our x as well. So we end up with 180 take off our 90 is just 90 degrees, and we've also got to take off our x as well. So that angle there ends up being 90 take x, and our final reason are angles in a triangle equal 180 degrees. And we get 4 pretty tricky marks.